nada más con este, acá.
Ok, bueno, muy buenos días a todas y a todos. Bienvenidos al seminario del Departamento de Estudios Económicos del Colegio de la Frontera Norte. Le damos la bienvenida a los investigadores, a los estudiantes de UABC también, ¿no? Y a los de Colegio que ahorita se van a incorporar. Bienvenidos. Bueno, el día de hoy tenemos una ponencia que seguramente va a estar muy interesante. Nos acompaña la doctora Isabel Treviño de UCSD, Universidad de California, San Diego. Ella es una economista joven, pero bueno, muy destacada, ¿no? Que hace trabajo de primer nivel. Un poco distinto, ¿no? Más teórico, más experimental a lo que normalmente se hace aquí en el Colef, pero por lo mismo va a ser muy enriquecedor, ¿no? Y seguramente vamos a aprender mucho. Bueno, la sesión del día de hoy la va a moderar el doctor Óscar Peláez, investigador del Departamento de Estudios Económicos. Bueno, antes de ceder la palabra al doctor Peláez, bueno, agradecerle a la doctora Treviño que nos acompañe y también agradecer al doctor David Gaitán su colaboración con la organización de este evento. Adelante, Óscar, gracias.
Bueno, gracias, Pedro. Bueno, primero darles los buenos días a todos. Leo la semblanza de la doctora Treviño. Es doctora en Economía por la Universidad de Nueva York. Actualmente es profesora del Departamento de Economía en la Universidad de California, San Diego, donde labora desde el año 2014. Anteriormente trabajó en el Banco de México en el área de investigación económica. Sus líneas de investigación se centran en las áreas de teoría microeconómica, economía experimental y economía del comportamiento. Entre sus publicaciones destacan artículos en revistas como Econométrica, Journal of Economic Theory, Experimental Economics, Games and Economics Behavior y Economic Inquirer, entre otras. En 2021 recibió el premio de excelencia Vernon L. Smith en finanzas experimentales por su trabajo Informational Channels of Financial Contagion, publicado en Econométrica. También ha sido dictaminadora de diversas revistas como Quarterly Journal of Economics, Journal of Political Economy, entre otras. Bueno, y sin más, el trabajo que hoy nos va a presentar se titula Descubriendo sesgos en la elección de la información y su uso, el papel de la incertidumbre estratégica. Lo va a presentar en algo más de una hora y posteriormente los presentes podrán realizar preguntas, intercambiar opiniones. También tenemos algunos investigadores conectados por internet, entonces bueno, ellos también podrán participar. Yo creo que ya sin más le cedo la palabra a la doctora Treviño para que nos presente el tema. Gracias.
Muchas gracias. Primero, muchas gracias por la invitación. Estoy muy contenta de estar aquí, conocerlos un poco mejor. Me disculpo, la presentación va a ser en inglés. Toda la investigación la hicimos en inglés y creo que si empezara a hablar en español terminaría hablando en inglés de todas formas. Entonces, bueno, si hay alguna pregunta, lo que sea, con toda confianza interrumpir para aclarar los conceptos. Bueno, ya, cambiamos de idioma. I'm going to start by motivating the question. So this paper is about information processing biases. And in the past 50 years or so, there has been an extensive literature that has documented biases in psychology and economics, starting with the seminal work from Kahneman and Tversky in the 70s. And what I mean when I say information processing biases is I refer to systematic departures from the Bayesian paradigm, right? So when we're thinking about models of incomplete information, when people don't know the state of the world, they observe information and then they have to update their beliefs. And in most of our models, we assume that people do that using Bayesian updating. But as I said, in the past 50 years or so, it has been documented that people have a very hard time doing Bayesian updating, and instead, there are some systematic failures of this type of Bayesian updating. There are a lot of, this literature has highlighted and characterized these biases, so we can think of specific examples like base rate neglect, which is the case when people neglect the information in their prior and they put too much weight on new information when they form their posterior beliefs. Overconfidence, when people tend to think that their private information is better than it actually is. Correlation neglect is another example, which is the case when people observe two signals that are correlated, but they update them as if they were independent. So, as I said, there's been, it's been a long time since people have been working on these biases, and this is obviously very important for our work in economics of models of incomplete information. But most of this evidence is coming from individual decision-making environments. That is understandable because those are simpler settings I mean with respect to strategic settings, where people observe information about, let's say, this unknown state, and they just have to update beliefs about that state. Now, in this case, as I said, agents observe signals about an unknown state of fundamentals, they update their beliefs, and they make a decision. No. Oh, okay, yeah, sorry. Sorry. But, in economics, we also have models of strategic interaction, right? So whenever the actions and beliefs of others also affect the actions of agents, then we do a different type of modeling, which is strategic interaction. Game theory is typically the way that we model these interactions. And there are a lot of, the theory of games of incomplete information is very vast, has a lot of applications, investment decisions, production externalities, etc. And in this case, when we're thinking about strategic environment, things get more complicated when it comes to updating information. So in this case, agents also observe signals to update beliefs about things they don't know. But this is more complicated because they have to update beliefs about those fundamentals that I was talking about, but also about the beliefs that other people have about those fundamentals, and also about the actions that those people are going to be taking, okay? So what we want to do in this paper, or actually I will finish my train of thought first. These literature, so we know that it is hard for people to form beliefs, to update information, when they only have to form beliefs about the state of the world. And when we are in this other environment, which is much more complicated, there is very little work about the difficulties that arise when it comes to updating information. So this is what we want to do in this paper. We want to understand how information is processed in strategic environments. And in particular, the research question has to do with the choice and use of information. So we want to understand how does the choice and use of information differ in strategic versus non-strategic environments. We want to understand what is the role of strategic uncertainty when it comes to these information processing biases. The way that we're going to answer this question is via theory. So we're going to write a model that will serve as the foundation or the benchmark against which we're going to compare our data. And we're also going to use laboratory experiments because at the end of the day, if we just write a model, we make assumptions about how people update beliefs, right? So we would be making those assumptions of Bayesian updating, let's say. So what we want to do is we want to, the point of this paper is that we want to identify those biases. So for that, we run an experiment where we ask real people to make decisions in this particular setup that I will show you. And we want to be able to identify how it is that they are using the different signals that we provide to them. And if can we identify systematic departures from the theoretical benchmark, which is the Bayesian benchmark? And if so, what are these departures? So we will do this in 3 steps. First, we want to know how do people acquire information, right? So again, we'll have our model that tells us this is the optimal information, right? So we solve an optimization problem. This is the optimal information that people should be choosing. That will serve as our hypothesis, but then we want to see how it is that actual people choose information, so we'll compare that to the hypothesis that comes from the model. Once we know what information people choose, we're going to take the next step, which is to understand how they use that, right? And that is where we're going to be talking about this more standard notion of biases. So for any type of information that people choose, the model will tell us what is the optimal way of using it, right? So if you have different types of signals, what is the best way to combine those signals? So we will have that benchmark, that will be the Bayesian benchmark, and we're going to identify with our data whether people do it that way, and if not, how is it that they're doing it? And once we identify biases in those 2 domains, the next question has to do with welfare, right? It's very good to say people are not choosing information or using information the way that the model says, but at the end of the day, we want to understand what are the consequences of this. So yeah, so we're going to quantify what the effects are on payoffs. You know, these, for those of you that are not familiar with experiments, you know, we bring typically undergraduates to play the game that I will show you in a second, and they're incentivized, so they get paid for their performance according to the incentives in the model. So I will talk about that in a few slides when I describe the experimental design. Okay, so the setup that we will use is a very simple setup. So it's simple enough that, you know, it's not too hard to implement or to show subjects in the lab, but it is rich enough that it has a rich information structure, and it allows us to shut on enough strategic uncertainty, right? So I started by saying that we want to understand the role of strategic uncertainty in information processing biases. So in order to answer that question, we need to have two settings, one with and one without strategic uncertainty. So we're going to have this model where just with one parameter, we can shut that strategic uncertainty on or off. In terms of the information structure, there's an unknown state of fundamentals. We're thinking of, I'm talking about everything very in an abstract way, but there's a lot of applications. So let's just say if we're thinking about investment decisions, there's an unknown state of fundamentals, which could be the return to investment. Agents don't observe it directly, but they get noisy signals about it. They get noisy private and public signals about it, so we can think of a public signal as a central bank announcement of, you know, the soundness of the economy, and a private signal would be information that is only available to them. So let's say an investor has access to a research team that prepares a report that only that investor can observe and none of the other players can observe it. So that would be the private signal about the state. And we assume that these private signals are costly, right? So these team of people that are preparing the report that is only observable by that one particular investor, it is costly to prepare that. So that's how we're going to introduce information acquisition. In terms of actions, as I said, we're going to have the strategic and the non-strategic model. For the non-strategic model, which is the individual decision-making model, we're just going to say that agents have to match the state, meaning you have to make a decision that is following the state of fundamentals, okay? And in the strategic case, you have to do two things. You have to match the state, but also the actions of others. So you want to choose a number that is close to the state and also to the actions of others. This is what is known as a beauty contest game. For those of you who are not familiar with this idea of the beauty contest game model in game theory, it comes from Keynes. So he made the observation that investment or trading in the stock market in the short run is similar to a beauty contest game back then, where people had to choose. So there was this contest in the British newspapers back then, where there were pictures of pretty ladies, and people had to choose not the lady that they thought was the prettiest, but the lady that they thought that everybody else would think is the prettiest. So that's why it's called a beauty contest game. And what is behind this, just in terms of modeling, is strategic complementarities. It's a coordination game. Okay, so you just want to coordinate with others. So if we're thinking, you know, again, of investments, if we think, for example, of, you know, a return to investment, you know, the return to investment, we can think that the return to investment will be higher if there's more aggregate investment, right? So I want to invest in a project if the returns are higher, which is a direct measure of the fundamentals, but also if I believe that there's going to be more aggregate investment, because that makes the return to investment more likely to be higher. So I want to do what others do. So that's kind of the idea of this, of modeling it this way. Okay? Any questions? Okay, so if there are no questions, I'm going to start with the theoretical model. I'm not going to take too long in the model, just because I think the more interesting thing comes with the data, with the experiment. But I do want to, you know, just explain to you what the framework of this is. So as I said, we're going to use the beauty contest model. with two players. So two players, I'm going to show you first the strategic case, and then I will show you the simpler case, which is when we shut down the strategic motif. So we have two players. We only want, this is, this is a very simplified setup. It is, it's not trying to capture like the economy as a whole, but what we do with experiments is that we try to, simplify the setup as much as possible to kind of like strip it down to its basic components to really understand, just keeping the tensions and trade-offs. I think hay una pregunta, ¿no?
Alejandro, ¿tienes una pregunta? ¿Puedes formularla? No sé si es ahí dentro. ¿Cuál es el sonido aquí? Espera un poco, Alejandro, que ahora mismo no escuchamos aquí en la sala. Alejandro,
sí.
Ahora sí se te escucha, adelante.
Gracias. Good morning. I have a question. You were talking about the beauty contest in players in Morris and June 2002. Are there any unique equilibrium contests with complete information in this model? Is this model complete or incomplete information? And there have been other studies, like in recent years, and they find general conditions under which the given contest would admit a unique blur strategy Nash equilibrium. So that, in contest theory, which is, I think this is what we're using in the beauty contest theory, there would be different kinds of information for the two players. It's a two-player contest, right?
Yep.
I don't know if I'm making sense in what I'm asking.
Yeah, so I'm going to, thank you. Thank you for your question. So I'm going to, so in the next couple of slides, I'm going to be defining the setup, and I have a slide precisely about equilibrium, and we will have a unique equilibrium. Yeah. So this is a game of incomplete information. The complete information case would be a case where you don't have a unique equilibrium in the sense that, well, let me think. Yeah, so if we all knew this, if we all knew the state, then yeah, we would just choose the state. So it's actually a unique equilibrium, yeah, of course. Yeah.
Thank you.
Of course. Thank you for your question. Okay, so yes, this is a two-player game. There's an unknown state of fundamentals. We're going to call that theta. And as I was saying before, players don't know theta, but they observe noisy public and private signals about it, and they have to choose an action, which we call A sub I for players 1 and 2. Now, they choose this action in order to minimize the distance, the squared distance between their action and two things. So one is the state, right? So that would be the theta, and that would be that term. Wait, should I do it like this? Yeah, so that would be this term. They want to minimize the distance between their action and the state, and then their action and the action of the other player. So that would be AI minus AJ. There's a parameter alpha that determines the importance of these, or each of these terms. So we can think of alpha as a parameter that captures the strength of strategic complementarities, right? So if alpha is high, then it is more important to match the action of the other person. It really is it's purely a coordination game. If alpha is low, or if alpha, to the extreme, if alpha is 0, then it is all about matching the state, okay? I've been talking about, we're interested in understanding how people use information, but also how they choose it. So this is a two-stage model, where in the first stage is the information acquisition stage. So in the first period, theta, which follows a normal distribution with mean mu and variance sigma theta squared, is realized. Players don't observe it, but they, at the same time, they privately choose the informativeness of their private signal. which is determined by a noise parameter sigma I, and this has a certain cost. Now, we have normal distributions, so we have variances, but I'm going to be talking a lot in terms of precision just because it is a more, I guess the concept is more natural, and it's also the concept that we use in the experiment. So in this case, precision is just the inverse of the variance. So there's going to be a cost associated to this choice of precision. Is that para nosotros? No. So there's a cost associated to that precision, and in particular, we're just going to assume that costs are convex in precision, following Colombo, Feminist, and Pavan. So anyway, first stage, the state is realized, players don't observe it, but they choose how informative they want their signal to be. In the second period, they observe their private and public signals, and their private and public signals are going to be, they're going to have a very simple form that is also very illustrative of this idea of precision. So remember, they care about the state, but they don't observe the state. So both the private signal, which we call xi, is distributed normally around this value of theta that is unknown. And how close it is to this value of theta depends on the noise parameter, which is the precision parameter, the sigma I squared, which they are choosing in the first period. On top of that, they also observe a noisy public signal, which we call y. That signal is also distributed normally around the value of theta that was realized, and it has a precision parameter that is exogenous. It's sigma y squared. Once they observe their signal, so again, let's just think in terms of timing. They choose their action, they choose their position, the position for their signal, then they observe their actions, and then then they observe their action. Okay. So going back to the timing. So first period, they choose the position of their signal, then they observe their signals, and then they choose an action. And they choose an action to maximize the utility function that I showed you in the previous slide, but now we also care about, right, there's a cost to information here. So as I said, I'm not going to go into too much detail, but I do want to show you the equilibrium result. So as I was saying before, we show that this beauty contest game with costly information acquisition has a unique equilibrium where in the first period precision choices are optimal and symmetric. So we're going to drop the subscript I, or 1 and 2, and now we're going to say that in equilibrium they both choose the same precision, which is determined by the standard deviation sigma. And action rules are optimal given the precision choices and their beliefs, and they are given by this linear rule. So what we see here is that optimal actions are just a linear combination of private and public information. And these parameters, beta and gamma, are very important. So beta and gamma depend on all the parameters of the model. So that means all the noise parameters, but also on alpha, which was the strength of complementarities. I want to spend 1 minute here just to say something about these coefficients, because this is going to be important for when we look at the data. So in equilibrium, precisions are symmetric, so that's why we drop the subscript here. And that's why in the second stage, the equilibrium of the second stage, there is no subscript here for beta and gamma. However, when we look at the data, when we look at the experiment, people are not necessarily going to be choosing symmetrically their precision choices. So what we're going to be doing is that we're going to estimate econometrically these weights for the subjects in the experiment. And for that, what I want to highlight right now is that each of these parameters, beta and gamma, do depend on the precision choices of both people. So when I show you the data, we're going to be separating people depending on the composition of precision choices in that pair. So people that choose a certain precision and the precision choice of their opponent, etc. Okay? Maybe this is not very clear right now, but it will be clear later on. Okay, so that's the strategic case. The non-strategic case is very simple. So we shut down the coordination motifs, we shut down strategic uncertainty, and the way to do that is that we just set alpha equals to 0. What that means is that Remember, alpha was multiplying that square distance term between my action and the action of the other player. So if we shut that down, if we make alpha equal to 0, then I don't care about coordinating with the other person. So then this stops being a game, right? So we shut down any strategic motifs here. So when that happens, and we're going to have exactly the same information structure, but now the game is sorry, it's not a game. But now the setup is going to be very different because it is a setup of, it's an individual decision-making task. So now I'm going to observe signals about the state, and I have to choose an action that is closest to what I believe that state to be. Okay? So we're going to drop all the subscripts. So that's what we're doing here. And we're going to choose, but agents still are going to be making these two choices. They're going to choose a precision for their signal, and they're going to be choosing an action. But as I said, now the only thing they want to do is to match the state. Okay? And the optimal action rule is going to be similar. We're going to have that optimal strategies in equilibrium are going to be just a linear combination of private and public information. But now these weights, this beta hat and gamma hat, correspond just to the Bayesian weights. Okay, so this is like a pure Bayesian updating task. And as I said, we're going to use this as the benchmark for our data. Okay? Any questions about the model? All right. Okay, so let me tell you about the experimental design. So as I said, what we do here, for those of you who are not very familiar with experiments, is that we basically take this setup that I just showed you, and we bring undergraduate students to the lab. The lab is just a room with computers, and we explain what they have to do. So they just have to, we do a between subjects design. What that means is that each treatment, so each variation of this game, is played only once by subjects. So, for example, where we have, I'm talking about having strategic and non-strategic motifs. Well, people either play in a case when there's strategic motifs or where there's no strategic motifs. We're not changing treatments for the same people. That's what between subject design mean. They're going to play the game for 40 rounds. We do random matching in each round, right? So this is a game of 2 players. So they're playing pairs, but they don't get to play with the same person in every round. Instead, every round we rematch them. The reason to do this is that we want to avoid any repeated game effects. So if this was a repeated game and you're playing with the same person, then you can come up with strategies that have to do with the choice that you make in one period depends on the outcome of the previous period, etc. So that's why we do random matching. We're going to choose parameters. So for the distribution of theta, we choose mu to be equal to 0 and sigma theta to be equal to 18. And there's going to be 3 main dimensions in which the experimental treatments will vary. So the different ways in which people are going to be playing. Obviously, strategic motifs, right? So that was the first question. How do they play when they're facing strategic forces versus when they don't? We're going to have the case with individual decision making, which is, as I was explaining, the case where alpha is equal to 0. In that case, people come into the lab and we say, you're going to play for 40 rounds. And each period, there's going to be a number that is going to be drawn from a normal distribution that has mean 0 and standard deviation of 18. And we do explain what this means. We give them some training. And you just have to choose an action. And we're going to pay you according to how well you match the state. So they do that for 40 rounds. A different group of people will come on a different session, and they will play the game with complementarity. So when alpha is higher than 0, and we're going to vary the string of complementarities. We're going to have 2 values. One is weak complementarity, so alpha is equal to 0.25. This is going to be our benchmark case for the strategic treatment. But we're also going to do one with strong complementarities where alpha is equal to 0.75. And the reason to do this is to understand the robustness of our results. So what happens when we're talking about the effect of strategic uncertainty on these choices. So our benchmark will be a case where there is strategic uncertainty, but the strategic forces are not that strong. But we want to sort of test and push our results to a case where the strategic forces are much more important. So that will be the case of strong complementarities. So that's the first dimension in which the treatments vary. The second dimension is the precision of private signals. So we want to understand how people choose information, and for that, we need private signals to be endogenous, right? So that people can actually choose this information. But we want to be careful when we design the experiment to not over-attribute things to the fact that this information is chosen, right? So we're going to run some controls where private information is exogenously given. So we, as the experimenters, are choosing the precision of the private signals and giving to them exogenously, again, so that we can see what is the effect of endogenizing information. And finally, the third dimension in which the treatments will vary is the transparency of public signals. So that just means how informative the public signal is. Our benchmark case will be one where the public signal is very informative, so the standard deviation is 1. But we also want to test what happens when public information is not very good. So when the public signal, the standard deviation is 15. The reason to do this is that private and public information can be, so public signals and private signals, obviously they give people information about the state. But when we include costly information acquisition, then there's a trade-off there, right? Because you get public information for free, but then you also have the chance to buy private information. So in the case when public signals are very good, so when the transparency is high, which will be our benchmark case, there's a very clear trade-off. If public information is very good, then a rational agent should not be spending too much money in buying private information because I already have very good information. However, when we make public information noisier, then the incentives to acquire private information increase. So that's something that we also want to understand. We have 452 subjects, so these were 452 undergraduates that participated in the experiment. As I said, we give them, practice screens for informations and payoffs to understand the setup better. Yep.
Excuse me, before you go further about the experimental design, could you please, I couldn't find out where is the state of information in the experimental design. Could you please explain it? As the state, you mean the information data set or the state of the information? What does that mean?
I'm trying to go back on the slide. You mean when I talk about the state, like that theta that I keep on calling the state, or
That's what is confusing about.
Yeah. Okay. So just in terms of how or actually, you know what? Let me think. I think in a couple of slides I will go like one by one, like the timing in the experiment. So maybe I'll go back to that. And if that's not clear, we can go back to the question. Yeah. You know what? No, I'm going to try to answer now because if that's not clear, then it's better to stop. So every round, they will. So in the model, remember the state. So the state variable, right? The thing that they care about, the variable, the state of fundamentals, which is this theta. They don't know it. In the model, we call it theta, and we can write it down, etc. But in the experiment, they literally don't know it. They don't observe it. But we explain in the instructions, and we're very clear about how, for their payoffs, there is this unknown number x, we call it x, that they are not going to observe, but they're going to have to try to match it. And instead of observing the state, we're going to be giving them hint numbers. We call them hint numbers instead of signals in the experiment. So we say, we're going to give you 2 hints about the state. This is how precise these hints are. And then you have to just put that information together and see, and make a choice. And that's exactly what we want to do. We want to, with the experiment, what we want to understand is precisely how it is that they put this information together. Is that clear?
Yeah, probably. So the state in this experimental designs is reflected about the public signers or private signers?
Both.
Both. Okay.
Both. So that's exactly, yeah. So both of these things, so they don't know the state, but they're going to get these 2 hints.
All right.
One of these hints is observed only by them, and the other one is observed by the other. So if I match with Pedro, then he observes his own private signal, and he chooses the precision of that private signal. I observe my own private signal, and I choose the precision of that private signal. We don't know what precision we chose.
All right.
But on top of that, we both know that we're both observing one signal that is common to both of us. So in terms of an application, let's think that public signal, that common information, is an announcement by the central bank. Everybody sees that. But that announcement is not perfect, right? So it tells us something about the state of the economy, but it's not perfect. And then on top of that, Pedro goes and does his own analysis of, gathering information from a lot of other sources, and I do my own thing. And we come up with different estimations. So that would be my private information, his private information. And what's important here is that since we care about matching the action of the other person, then it's going to become very important for me to form beliefs about what information Pedro has.
So that's the case of the second design.
Exactly. So that's it. And that comes from strategic uncertainty, right? So when I care about matching what you're doing, then I have to spend time. So I care about what action you're going to take. But in order to form beliefs about the action that you're going to take, I need to take a step back and form beliefs about the beliefs that you're forming. And that implies me thinking about what information you hold that I don't share with you.
Okay.
So that's why this is so complicated. And in all of these game theoretic models, right? So that's the thing in equilibrium, that it's this idea of common knowledge, that in equilibrium I know that you know that I know that you know that we know everything. And these models are very nice mathematically and everything, but that's one of the reasons why we're running these experiments, because we want, this is hard. This is not how people work, so we want to understand how it is that they form beliefs.
Thank you.
I have one question. So they know the precision of their private signal and the public signal?
Yeah.
And they know the precision of the other players' signals?
That's a very good question. So they don't, but this is a key component for our estimation of the weights. So what we do is that we elicit their beliefs in the experiment. So all we care about, right? So when I was showing you those weights, those betas and gammas, that gives, that tells you how much weight to put on each type of information, private or public. And those betas and gammas depend on the precision of the public signal, the precision of my private signal, which I know, but also on my belief about the precision of your private signal. So they don't observe it, but in order for me to be able to estimate that and compare it to the right theoretical benchmark, what we do in the experiment is that we ask them, so they choose the precision of their signal, and then we ask them, what do you think is the precision that your partner chose? So that might not, and we incentivize it in the sense that we say, if you guess correctly, we're going to pay you $5 extra at the end. So that's just, it's all about incentives. So we elicit beliefs that way, and then once we have all of that, then we can actually, we estimate weights for their information, and then we know what is the right theoretical benchmark to compare that to. But yeah, that's a good question. Okay, in terms of private information choices, so in the theory, right, we just said they choose a precision, but here, what we decided was to do a menu of 4 precisions and choices. When I say precision, now this is just a label. Precision 1 is just the best precision. Precision 4 is the worst precision. What that means in terms of noisiness, that table shows you. So precision of 1 has a very small standard deviation, a standard deviation of 0.5. So this is a very good signal, and it has the highest cost. We're going to be talking here in terms of points, and then we will I will explain to you how we convert points into dollars. So precision 1 is the best precision, so very small noise and very expensive. Precision 4 is the worst precision, but it's the cheapest. So we give them those 4 choices. As I said, so in terms of payoffs, I came with a very complicated experiment today, but anyway, just bear with me. In terms of payoffs, so we give them an initial endowment of 12 points. The reason to do that is because we want to give them enough money at the beginning. If they want to buy the best precision, they have all the money to do that, right? So they don't feel like they're losing money. So we give them 12 points, and then they can choose the best precision if they want. The payoff function, so what I showed you in the theory, these really are, they're quadratic loss functions. So when we do the optimization, when we solve the optimization problem, we're minimizing losses. Now, in the lab, when we bring people to participate in the lab, we're going to pay them, so we have to do something to, we can't have losses in the lab. So we did two things to take care of that. So one is that we added just 100, right? We just added a number at the beginning here. And then so this is just the new, so we scaled it up by 100. They played for 40 rounds. We choose one round randomly for payment. The reason to do this, so there's different ways of paying in experiments. We could have paid them for their performance in all 40 rounds, but if we do that, then the stakes for each individual round are very small. So what we said is that we're going to choose one round at random, and what you do in that round is going to really matter to kind of like increase the stakes. And even if we added this 100 there, they can still make losses, right? So if they mismatch the state by a lot, or if they mismatch the action of the other person, these negative signs could still be higher than 100. So the way that we get around that problem is that we pay them with what we call in experimental economics, we pay them with probability points. So what we said was, okay, you're going to play this game, and you're going to make a certain number of points in a round. So those points are going to be, they're not going to be converted to dollars directly, they're going to be converted to probabilities. So they are converted to probabilities, and then they will play a lottery that pays $20 with probability P and $5 with probability 1 minus P, and this P is going to be a linear function of the points earned. So basically, the more points they earn, the larger this P is. If they match the state and they match the action of the other person relatively well, they will have, let's say around 100 points. Well, if they match it perfectly, but their P will be, the number of points will be significantly high. So then when they play this lottery, they will be playing a lottery that pays them $20 with, let's say, 90% probability. So they will be paid according to this lottery, but their performance in the game determines the probabilities in this lottery. As I said, P is a linear function of the points earned. Just for symmetry, so the highest number of points that they can make is 112. That is, if they don't buy precision, or if they choose the lowest precision, and if they match the state and the signal perfectly. So we say that if they do that, so if they get the highest number of points, then they get the $20 with probability 1. Just for symmetry, we say that if they get minus 112 points or less, they get the $20 with probability 0, so they get only the $5. On top of that, we pay them a show-up fee of $10. So if they do very well, I mean, they can leave with the experiment with here would be $30, but if they guess the precision of the other person correctly, they can leave the room with up to $35. Just to, go step by step what happens in each round. So remember, they play this game 40 rounds, and in each one of these rounds, this is the way that it happens. So first, they choose the precision of their private signal. And as I was saying to Pedro, answering to Pedro's question, we elicit their belief about the precision choice of their opponent, which is going to be very important for the estimation. Then they observe their signals, public and private signals. Then they simultaneously choose their actions. We help them by giving them what we call a hypothetical payoff calculator. What that just means is that, right, we're giving them these we're paying them with these quadratic loss functions that are complicated. So we give them a calculator where they can enter, if this was the state, this was the action of the other person, this was my action, what would be my payoff? So we help them in that sense. And then after each round, they receive feedback about the state, the signals they observe, their actions, their precision choices, and their individual payoff. And then they move on and play the same thing with completely new numbers and with a new partner. Okay, and they do this for 40 rounds. Okay, so I'm going to present to you results, first about information choices, and then about how they use information. So I'm going to be focusing on the baseline condition, which is the case where public information is very good, and so that would be the sigma y equals 1, and then the individual case, that's alpha equals 0, and the strategic case is alpha equals 0.25. So there are three things that I want to highlight here. So what you have here, sorry, I'm realizing that that font is tiny on the axis, sorry. Okay, so these are histograms for precision choices. And in the x-axis, we have the 4 possible levels of precision. So precision 1, which is the closest to the y-axis, is the best precision, and then we go precision 2, 3, 4. So there's 3 things that I want to highlight from this figure. The first one is how similar, qualitatively similar these choices are for individual and strategic case, right? So that's one thing we want to understand, if choices differ across these dimensions. So they're very similar. The second thing I want to highlight is there's a high frequency of equilibrium choices. So the equilibrium in this case is precision level 4, which is in the black bar. So the highest frequency of choices is equilibrium for both of these setups. But the third thing that I want to say is that there is a sustained over-acquisition of information, and in particular, people seem to really like precision level 2. Okay? Now you might say, well, if the equilibrium prediction is the lowest precision, then any deviation is going to be over-acquisition. So, you know, what's going on here? Sorry. So we're going to make use of the treatment with a low precision of the public information, because as I was saying before, there's a trade-off between private information acquisition and the transparency of the public signal. In the case up there, sorry, public information is very good. So in equilibrium, the incentives to acquire private information are very low, which is why the equilibrium prediction is level 4. I should not be investing in private precision. My public signal is good enough. When we change the precision of the public signal to a low precision, then all of a sudden the incentives change, right? My public signal is very bad, so now it's worth it for me to spend some money and get a better private signal. So when we do that change, now the equilibrium prediction is level 2, so we can see that there in those black bars, level 2. And we see exactly the same 2 things that I was telling you before. We see high frequency of equilibrium choices, so the model choice in both of, well, we see the 3 things. We see very similar behavior in individual and strategic setup. We see the high frequency of equilibrium choices in both cases, but we also see a sustained over-acquisition of information. So here, deviations could go in either direction, but we see that the deviations are going mostly towards over-acquisition. So in terms of biases that we could see in the choice of information, we would identify an over-acquisition of information. Okay? Okay, so this is basically what I said.
Oh, so I have one question. When does over-acquisition happen? When is it? But they choose a very precise...
So, sorry, yeah, so what I meant, yeah, I should have... So when I say over-acquisition, I mean in terms of what the theory says that they should be doing, the optimal rational choice. So over-acquisition happens when, and this is why I'm sorry, the font is so small on the graphs. I think that would be clearer if I had chosen a larger font. So, okay, so up here, you have the precision level. So precision level, so 1 is the best precision, and 4 is the worst precision. So over-acquisition would be anything to the left of the equilibrium, right? So this would be the optimal choices. Anything to the left is over-acquisition. And here in particular, precision 2 seems to be the popular level of over-acquisition. And the reason that I show you the other one was because here, right, deviations can only go in one direction, which is the direction of over-acquiring. But in this case, when the equilibrium tells you that you should choose a relatively high precision, then people that are not choosing the equilibrium precision, the question is, what are they doing? And we see very clearly that they tend to over-acquire because they're paying too much. They're paying for too much information. They don't need that much information, according to the rational model. Okay. Sorry, I don't know where. Okay. Yes, so so in terms of a bias that we identify is the sustainable acquisition across levels of transparency of public information. But also, as I was saying at the beginning, information choices are not really different in the strategic and non-strategic environment. So strategic uncertainty doesn't seem to be driving these results. Okay. Now let's go to the use of information, right? So this is what information people choose. Now we know what information people choose, but we want to know how they use it. So this is where we're going to be comparing. The theory predicts that they're going to do this linear combination of private and public information. We're going to estimate the weights using a random effects linear regression, where action choices is the dependent variables, and it's a dependent variable, and it's going to be a function of observed signals given the precision choices and their beliefs about the precision choice of the other person. We test for quadratic terms or higher order terms, but nothing is significant, so we stick to the linear specification. As I was saying before, for the strategic setup, we're going to present the estimated weights for combinations of my own precision sorry, and my belief about the other person's precision choice. And I apologize because these are the same, it's the same font in the axis. Okay, so let me explain to you how to read these graphs. Again, we're showing for the baseline condition where public information is precise and where we have the individual and the strategic case. So we're estimating weights, right? So on the y-axis, this is just weights, so from 0 to 1. On the x-axis, what we have is, well, first of all, that line, that vertical line is dividing the weights given to private signal, which is to the left, and public signal to the right. I'm going to focus first on the individual graph. So we're going to be focusing on the people that choose either the equilibrium precision, which was the modal choice, or the people that over-acquire. And for the over-acquirers, we're going to focus on the people who chose precision level 2 because that was the most popular, the second most popular precision. The black circles correspond to the theoretical weight. So what the theory says, so if I observe a signal, if I choose precision 2, what is the weight that I should be given to my private signal or my public signal? If I choose precision 4, so that would be here, right? So if I choose precision 4, what is the weight that I should be giving to my private signal or my public signal? And the gray dots correspond to the estimated weights in the experiment. Okay? For the strategic case, we do something similar, but it's a little bit more complicated because now what we have here, we can't just say the people that choose precision 2 or precision 4, now beliefs matter. So it's the people that choose precision 2 and believe their opponent chose precision 2, so that would be this group of people, and these would be the weights for the private signal and the weights for their public signal. People that chose precision 2 but believe their opponent was choosing precision 3, chose precision 2, believe their opponent was choosing precision 4, or people that chose precision 4, believe their opponent was choosing precision 2, or chose precision 4 and believe their opponent was choosing precision 4. I hope it's clear, the graph. Okay, so what we care about here when we're thinking about biases in information processing, what we're looking at is how different the black and the gray dots are. Okay? So, and remember, we're comparing across individual and strategic behaviors, so or strategic environments. So the first thing that we can see from this is that we do see very significant differences in behavior across these two environments. In particular, we see an overuse of private information in the strategic environment, and this is especially strong for the over-acquirers. When I say an overuse of private information, what I mean is that if they choose precision 2, and this is relatively, constant across beliefs about the precision choice of my opponent, the theory says that I should give my private signal a weight of about 0.15. So these are the Bayesian weights, right? This is doing Bayesian updating and telling me how good that signal is compared to the public signal, right? Because remember, I have two pieces of information. So because my public signal is so good, so remember we're looking at this case, then the theory tells me you should put most of the weight on the public signal, like 0.85, and then the remaining on the private signal. That makes sense. My public signal is better, right? And also, because it's public, it allows me to coordinate better with the other person because the other person is also looking at it. However, people don't do that. They're doing the opposite. They're thinking that their private signal is better than it is. And instead of just giving it a weight of 0.15, they give it a weight of like, 0.43, let's say, across these different levels of beliefs. And what that implies, obviously, if you're giving the private signal a lot of weight, that means that you're reducing the weight that you give to the public signal. So this is where the disparity comes from. So we see, so that's why we call an overuse of private information. They are using it too much. They think their private signal is better than it actually is. So we see this overuse of private information in the strategic environment, especially for the over-acquirers. The first question that we thought of was, could this be due to a sunk cost fallacy? Okay, so sunk cost fallacy just says that, so in our models, right, precision choices are sunk costs. So I already paid for it. So once I pay for it, I forget about it. But there could be an issue here with sunk cost fallacy, which is, well, I am an over-acquirer. I paid a lot of information. I paid a lot of money for this information. So now I'm going to make the most out of it and I'm going to pay for it. So it's the opposite of thinking of it as a sunk cost. So in order to explore whether this could be what's driving the results, we run the same experiment, but without costly information acquisition. We just give them the precision of their private signal, right? So we run an experiment where we exogenously give them private signals of precision 2 and private signals with precision 4. And those triangles correspond to the weights estimated for those two cases. When we're looking at experimental data, we typically focus on qualitative results, not necessarily point estimates, because obviously, we need to. We're running this in a relatively artificial setup with undergraduates in a computer lab, so it's hard to say that the point estimates that we're seeing in the lab are going to translate to other contexts. So that's why we typically focus on comparative statics or directions of where things are moving. So in that sense, the magnitude of the bias does decrease when we remove costly information acquisition, right? We see this triangle a little bit lower, so they're still overusing private information, but not by that much. But it doesn't take it away. It doesn't go away. So we see that it's not due to sunk cost fallacy. And I had a link there, but I don't know I think they would have to click on it, but it's fine. You can believe me that this is robust, stronger complementarities. We see the same type of graphs when we have stronger complementarities, and if anything, when with stronger complementarities, the sunk cost fallacy is completely gone because they overuse as much private information in that case. So in terms of, just to kind of like stop for a moment, the results I've showed you so far. In terms of information use, we find that the strategic environment does not seem to affect information choices. People choose in the game as if they were in an individual decision-making task, which by itself is a little bit surprising because in the strategic, since they share the same equilibrium prediction, obviously the fact that they're choosing, the vast majority of people choose equilibrium, it's not surprising that it would be the same in both of them, or at least we cannot say it's surprising because it is the equilibrium prediction. But when we're looking at off-equilibrium choices, it is surprising that we see the same deviation, which is over-acquisition. And the reason that I'm saying it's surprising is because in the strategic case, so I was talking before about how actions are complementary. So I want to do the same thing that you do. And something that I didn't say in the model is that in these type of setups, in this type of coordination games where I want to do what others do, there will also be strategic complementarities in information choices. So what that means is that if I want to do what you do, I also want to know what you know. So these type of strategic forces of equilibrium could mean something to help people choose information, but we don't see differences in these environments. And in terms of biases, we see a sustained overacquisition across treatment conditions. In terms of information choice, we see near optimal use of information in the individual decision-making environment, so people actually use information pretty well. But the strategic environment leads to a bias that takes the shape of an overuse of the private signal, which is especially true for the overacquirers. This gives us a first hint that some of these well-known biases might behave differently in strategic environments. Now what I have next is that, so this is just like, identifying the anomaly, right? This is all I've given you. So this is what they should be doing, or not they should be doing. This is what the model says that they should be doing, and this is what they do. So I'm just identifying anomalies. What I have next is trying to understand the mechanism for these anomalies. Why are they doing it? What is going on? But I'm going to stop and ask you how much time I have.
Serán unos 30 minutos, tal vez, para...
Una hora.
Una hora, ok. Ok, perfecto. Gracias. Bien, bueno. Okay, so let me now tell you why they overacquire, why they overuse, or at least, what are the dynamics that lead to this overacquisition, et cetera. Okay? So I'm going to start first with the overacquisition. So why do people overacquire information? There is some evidence of overacquisition of information in individual decision-making environments. We call that of instrumental information, right? So it's information that is actually relevant. These are all experiments, what I'm showing you here. So Conlon, Healy, and Yoon, Rashidi, Lizeri, Yarif, Chan, and Swen, they show, it's very different tasks, but they do show that there is a tendency to overacquire information. So, there's some heterogeneity here that leads to this tendency to overacquire. There are only 2 papers that I found where there's some overacquisition in strategic environments. One is in auctions and the other one is in political committees. So one question is this just due to pure heterogeneity? Do people have intrinsic preferences for better information? And can we identify learning dynamics, right? So is what could be going on here? So let's look at the dynamics of information choices. And something that I didn't say explicitly, but I had it in the slides, but with small font, was that the results that I showed you so far are results for the last 30 rounds of the experiment. So once behavior has stabilized. The reason that we typically do that is because we want to understand kind of that behavior that they're converging to. So now what I'm looking at is, I'm going to show you the same histograms for precision choices, but for the first 10 rounds of the experiment. So we want to see what it is that they do at the beginning. How do they get to the results that I showed you before? It's the same as before, so individual and strategic case. And we have here the highest precision, 1, 2, 3, 4. Again, precision 4 is the equilibrium. But now we see 2 different scenarios. So first of all, in the individual case, we actually see a lot of heterogeneity. There's a little bit, people are choosing a little bit of everything, right? We could say that it's relatively uniform, the choice of precision in the individual decision-making case in the first rounds, the first 10 rounds. So this is not the model choice, and people are choosing a little bit of everything. In the strategic case, on the other hand, at the very beginning, there's a very clear tendency to overacquire information. So we see a lot of people choosing 2, even though that is too much information, and we don't see this equilibrium being the modal choice. So what we can say here is that the strategic environment might lead to some preference for better information, at least at the very beginning. Okay, so we do see that. However, when we look at the behavior that they converge to later in the experiment, which would be more of a, I don't want to say long run because this was 40 rounds, but anyway, they start doing something and then they come up with a strategy, they learn how to play in the game, and they do something very different. So what we want to understand now is, despite the fact that there were some differences in environments at the beginning of the experiment, can we identify learning dynamics that led to what we observe in later rounds, right? Which is that they behave very similar in both environments, and how do they move from what we're seeing here to those other graphs where almost everybody's choosing precision 4, and then there is some overacquisition towards precision 2. So in order to do that, I'm going to show you here some transition matrices. So what these matrices show, so these are precisions 1, 2, 3, 4. Remember, precision 1 is the best precision, precision 4 is the lowest precision. Precision 4 is the equilibrium, and we see a lot of people over acquiring choosing precision 2. So the way to read this, and again, we have the individual and strategic. These are the matrices for the first 10 rounds, and then I'll show you the matrices for the rest of the experiment. And the way to read these matrices is that the entry, so each entry, let's say this 0.73, it is telling me the probability for one person, if they choose precision 1 in one round, what is the probability that they will choose precision 1 in the following round? Okay, and we do that for all of these. So when we look at the diagonal entries, what this is basically telling us is the stability of precision choices, right? So what is the probability that if somebody chooses one precision, they stick to that precision in the next round? And remember, this is for the first 10 rounds. When we see large numbers in the main diagonal, we can say that these are absorbent states, or relatively absorbent. What that means is that once you get to one place and you like it, you stick to it. So that's a way to read these numbers in the diagonals. When we see, and then all of the other numbers are, they're telling us, I was telling you learning dynamics, these transition matrices tell us how people are moving from one level to another. So a few things to notice from, and this is the first 10 rounds. So these are the ones that correspond to the histograms that I just showed you. So a few things to notice here. When we look at these numbers in the main diagonal, they're not super high, but they are relatively high, and in particular for the equilibrium precision, right? So once even in the first 10 rounds, when people are probably experimenting and getting to know the interface and the game, once you choose precision 4, 84% of the times you choose precision 4 again the next period. And for the strategic case, it's something similar, 77% of the times. So, even in the first periods, there is some stickiness, let's say, to these different precision choices. Something important is that we know there's an experimental literature that shows that people have a very hard time doing hypothetical reasoning, so counterfactual reasoning. It's very hard for people to think about what would have happened if I had chosen this instead of what I did. And what that implies here is that really the only way of knowing the benefits of a different precision is to experiment it. So people that are choosing high precisions to begin with, precisions 1 or 2, it will be very hard for them to know the benefits of cheaper information if they don't try it. So what I'm highlighting here are the transition probabilities from those high precision levels towards the low precision, right? So, and they're very, very low. So what this basically means is that the people that start off by choosing the highest precisions, that spend a lot of money doing this, they fail to learn the benefits of cheaper information because they just never try it. So if you're choosing precision 1, the probability that you will then switch to precision 4, so if you're paying the most for information, the probability that you will experiment with the cheapest one is 1%. And in the strategic case, it's 0. Like nobody moves in the first 10 rounds from the most expensive precision to the cheapest precision. So it's very, very hard for them to learn the benefits of cheaper information. Same thing for precision level 2, they're very, very low, these probabilities. So if we start with that initial heterogeneity and we try to understand how they're moving, we can already see that the people that are choosing high precision tend to stay there because they never learn the benefits of cheaper information. On the other hand, something that I showed you in the histograms of the last 30 rounds is that there are these two clear favorites, which are the equilibrium precision, that's level 4, and this over-acquisition in level 2. So these things that I'm highlighting are showing us how it is that they move. So the people that choose precision 1 tend to either stay in precision 1 or they move mostly towards precision 2. Some of them go to precision 3. The people that choose precision 3, some of them stay there, but we see a lot of movement to the other two extremes, right? So 23% of the times they move to precision 4, so these ones are going to the cheaper information. and 23% of the times they're moving towards a more expensive precision, and we see a similar movement in the strategic case. For the people that are choosing the most expensive precision, either they stay there, but we see a lot of movement towards precision 2, and for precision 3, again, there's a lot of movements either to 2 or to 4, and that is what leads eventually to those 2 higher bars in the last 30 rounds that are in 2 and 4. Okay? So that happens in the first 10 rounds. What happens in the last 30 rounds? So now, when we look at these main diagonals, now we see much more stability than in the first 10 rounds, right? So in the first 10 rounds, they were still moving around, but in the last 30 rounds, they seem to stick with what they know. Remember, I told you, if we see high numbers here in these main diagonals, then we can say that these are absorbent states. Now, look at in particular for the equilibrium precision, this is very nice, right? We see that once people choose the equilibrium precision, which is the cheapest precision, there's a 95% chance that they will choose the same thing the next period. So these are really absorbent, well, 98% for the strategic case. So these are really absorbent states. And why is that? Well, because they realize, by doing it, that once I choose, I don't have to spend a lot of money for a good private signal because my public signal is very good. So that's the only way to really know that. And that's the equilibrium, right? So that's why they stay there. We see also that the higher precisions are absorbent. They're not as absorbent as this, but they are still relatively absorbent. And if we look at movement also in those runs, we see a very similar pattern. So remember, we're still moving more towards precisions 2 and 4. Those are going to be the 2 favorites. So 4 would be equilibrium and 2 would be this over-acquisition that we've been talking about. So we want to see where the people that choose precision 1 and choose precision 3, where are they moving? And precision 1, they're moving mostly towards precision 2. So here, in the strategic case, it's very clear, right? So they either stick to precision 1 or they move to precision 2 because, as we were saying before, they really don't experiment with cheaper precisions. So they don't get to learn the benefits of less precise, cheaper precision. And the people that are in precision 3, they seem to move both ways. So either they go 2, so they over-acquire, or they go to the cheaper precision, and we see a very similar pattern in the strategic case. Okay? So it's the same type of learning dynamics. I didn't show you here I didn't do the same exercise for the last 10 rounds, but it's even clearer that it's really just between precisions 2 and 4. So by doing this, we can come up with more nuanced conclusions in terms of information choices. So strategic uncertainty might actually affect information choices, right? And we see that from the first 10 rounds that we saw a clear preference for over-acquisition in the strategic case, and in the individual case, it was more uniform. But even if there are some initial differences, the learning dynamics actually lead to convergence to similar distributions, okay? As I was saying before, the lack of experimentation with cheaper precisions is avoiding those people who initially are drawn towards paying more money for information. That stops them from being able to realize how much better cheaper precision is. Precision levels 2 and 4 act as absorbent states. And as I said, I didn't show you the transition matrices every 10 rounds, but basically what we find is that by round 20, precision levels 2 and 4 are really just purely absorbent in the individual case. And for the strategic, this convergence happens in round 30. It's a little bit later, but also strategic case is more complicated. Anyway, so that's what we find here in terms of how information choices are moving. Okay, so any questions about this overuse of information? No. Sorry, over-acquisition of information. In terms of, so that's us trying to understand why it is that people over-acquire information, which is the bias that we identify in the choice. The next thing that we want to understand is why do people overuse private information, right? So that is the thing that we identified that is only present under strategic uncertainty. This is not something that is present in the individual decision-making case, but it is also robust to different levels of coordination strength. We tried to do something similar to see if we could identify learning dynamics across different rounds of the experiment. So estimating those weights at the beginning of the experiment and see how they were moving, but we couldn't identify any learning dynamics. We tried to see if popular models of bounded rationality could explain these results. So I'm not going to go into details, but some of these popular models are models level K, so where people have limits in their strategic sophistication. Models of regret aversion, so people that really dislike regret, so then they make choices to try to avoid that regret. Models of quantile response equilibrium. This is a model where it's very similar to Nash equilibrium, except that in this case there's always a non-zero probability of people making mistakes, choosing something else by mistake. And we also looked at models of overconfidence, which would be relevant in this case because overconfidence means, it is related to assigning too much weight to private information, but these would not explain the over acquisition in the first period. Okay, so because none of these things worked, then we kind of take one step back. We go back to the theory or the theoretical foundations, and we try to think what it is about strategic uncertainty that could be driving these results. So what are the inferences that subjects have to make in our experiment? Well, they have to, in the individual case, they get signals about theta, and they have to make inferences about theta. So that's a very direct mapping, right? In the strategic case, they observe signals about theta, and they have to make inferences about theta, but they also have to make inferences about the action of the other person. So the first one is a direct mapping, but the second one is not very direct. In order to make inferences about the action of the other person, I have to make inferences about the information held by that other person. So I have to make inferences about the beliefs that the other person has. So again, these become more and more complicated mappings. In previous work, I have shown that people tend to have a difficulty to form strategic beliefs, and these can give rise to biases in the use of information. In those other papers, I didn't explore in detail how these biases might arise. This is a better setup to do that, just because we have these linear strategies. So as I said, what we're doing here is taking one step back. I keep on talking about strategic uncertainty. If we were to define strategic uncertainty in a very broad sense, we could think that it's the uncertainty about the actions of others. But strategic uncertainty can manifest in 3 different ways in this experiment. One is the uncertainty about the signal of the other player. This comes from the theory, and this is present in a Nash equilibrium, right? So once we're in a Nash equilibrium, there's like all these beautiful things that are happening mathematically. And in this case, beliefs are correct, people know the strategy of the other person, or players know the strategy of the other person, but there is still remaining strategic uncertainty because I don't know what information they have. I don't know their private signal. So I know how they're going to use their signal, right? I know their strategy, I know the weight, or at least I have correct beliefs about the strategy, but I still don't know the signal. So that is a strategic uncertainty that still remains in the theory, even in even in Nash equilibrium. Now, in the experiment, obviously, so we have that, right? People don't know the signal of the other person. On top of that, in the experiment, there's also uncertainty about the strategy of the other person. Because in a Nash equilibrium, which is kind of this extreme of rationality, we say beliefs are correct, etc. But in the real world, I mean, I might form beliefs about what strategy the other person is going to do, and by strategy is really just that rule of behavior, how much they're using each of their signals. But I actually don't know it, right? I am not in that fixed point world of Nash equilibrium. I don't know the strategy of the other person. So I don't know the weights. Not only do I don't know the prior information, but I also don't know exactly how they're going to use it. I can only infer, form beliefs. And then on top of that, there's a strategic uncertainty that only happens in the lab and that is not present in the theory, which is uncertainty about the rationality of the other player, right? So I don't know. Again, in the model, we make assumptions and we say players are rational. So, and there's not only are players rational, but in game theoretic models, there is common knowledge of rationality. So I am rational, I know you know I'm rational, I know you know that I know you're rational, etc. So we all know that everybody's super rational. And that plays a very, very important role in the models, and that's what leads to these notions of equilibrium. But in reality, I have 24 undergrads coming to the computer lab and they get to play this game, and they are told you're going to be randomly matched with somebody else in the room in each round, and you have to make the decisions. They don't know the information the other person has. They don't know their strategy. But on top of that, I don't know what they're thinking about the rationality of the other person, right? So even if somebody, comes, they read the instructions and they think they know what they're doing, they might also think, well, I don't know if the person next to me has any idea what this is about. So that's an added layer of strategic uncertainty that happens in the lab. So so we're going to be tackling each of these things separately. And I don't have a lot of time, so I'm just going to tell you whether it's this rationality of the other player. So we run the same experiment, but subjects play against computers that follow the equilibrium strategies, right? So that's a way of shutting that down. I still don't know the information of the other person. I still don't know the strategy of the other person, but at least now I can shut down that concern about the other person not having a clue about what this game is about. So I'll show you quickly the graphs. So this one here, this is the same graph that I showed you before, and this is the graph of when they get to play against computer opponents, and qualitatively it's the same issue. So these, the overuse of private information is not because they think their opponent is not rational. We see the same thing when they're playing against computers. So this is, that's a result. I don't have a lot of time, so I'm gonna skip this. I can just tell you quickly what we try to do here is just to talk about the other two notions of strategic uncertainty. We go back to the theory, decompose best responses in terms of beliefs, and find the three different sources of, or the three different places where strategic uncertainty could be messing up these beliefs. Okay, so it has to do with beliefs about weights given to signal. Anyway, I'm not going to go into detail. Three different sources, three different mechanisms, and we explore whether which of these mechanisms could be behind these results. We run some other treatments to shut down some of these mechanisms. So this is looking at when we give them the signal of the other player, or the best guess about the signal of the other player, etc. Okay, so let me I can tell you about payoffs quickly. Just a bit of a summary. Anyway, so just to say one last thing before I conclude. If we were to just summarize the main results in terms of biases, as we said, we see that both in the individual and strategic environment, we see over-acquisition of information. This seems to be, as I said, robust across environments, also across different parameter values. In terms of the use of information, we do see strong differences across environments. We identify this bias of overuse of private information only in the strategic environment. They are actually pretty good at forming beliefs in the individual decision-making environment. So there's something about strategic uncertainty that is affecting the way that players form beliefs. I didn't show you the details about the other sessions, but what we find is that the difficulty to form strategic beliefs related to the information held by the other person about the strategies of the other person are it's like a cognitive overload. It's making it very hard for them to then be able to process all this information in that uber rational way. But what I want to say now in the last few minutes that I have is I want to talk about payoffs. So we know that people over-acquire information, and we know that people use information in a different way that they should, so they are overusing private information. So we want to understand how bad are these biases in terms of payoffs, right? So I might not be doing what the theory tells me that I should be doing, but is it really bad for me? Are there really some bad consequences? The only way that we can say that here is in terms of how much money they have when they leave the room. So just to give you this quick summary, we see similar payoff patterns in individual and strategic environments, so another similarity. The people that acquire that equilibrium position actually make about the same as as what they would have made if they followed equilibrium actions. But there is a very strong payoff effect from over-acquisition of information. So there are very strong payoff losses for those who over-acquire. There is no payoff effect from bias in the use of information in the strategic setup. So for those people that are overusing the private signal, right, even though that bias seems to be strong and very persistent, in terms of money left on the table, it's very small. The effect is very, very small. However, over-acquisition it does have a very strong effect. Even in the there are some treatments where when they over-acquire information, right, they're getting better information. So even if that better information makes them play the game better, the second stage better, and they make more money than if they had played according to equilibrium because they match the state and they match the action of the other person better, they leave too much money on the table by choosing a signal that is too good. I mean, they don't need that signal. So the conclusion in terms of welfare would be that the over-acquisition bias is very strong and it's very costly, but the overuse bias is really, it's not significant. I'm gonna skip implications, applications, and I think I just said that, actually, so anyway, so yeah, I'll conclude here. Thank you.
Bueno, después de la presentación de la doctora Isabel Treviño, abrimos una ronda de preguntas, comentarios. Bueno, sí, sospechaba que el doctor Alejandro Díaz Bautista, que el tema le interesa, iba a tener alguna pregunta. Pues si quieres empezamos. Adelante, Alejandro.
Gracias, doctor. Thank you, professor, for coming to the Department of Economics at Colef and presenting your new breakthrough paper in, I think it's behavioral economics and game theory, and about choice and the use of information. And I think some of the main questions in your study are how people acquire information and how the use of information is acquired. Information acquisition in a flexible game framework with strategic complementarity, substitutability in actions, and a set of externalities are responsible for possible deviations between the equilibrium results and the efficient acquisition of information. And some recent studies have shown how the acquisition of private information affects the social value of public information. As they work on the comparative statistics of equilibrium welfare changes with respect to the quality of public information. How does the efficient or inefficient acquisition of information affect the welfare outcomes in the model? And you said that over-acquisition bias can be very costly. Thank you, Professor.
Yeah, thank you. I thank you for emphasizing this idea of efficiency, and I didn't emphasize it that much. Well, I didn't emphasize it at all in the model, so thank you for bringing that up. And yeah, so as you say, in terms of efficiency losses, I guess, yeah, the over-acquisition, that's what's really driving those losses, and they're significant. So something good about doing an experiment is that we can actually quantify those losses. Yep. Thank you.
Sí, muchísimas gracias por la presentación. No sé, revisando el paper y un poco siguiendo, tratando de seguir la presentación que hiciste, creo que no sé si reafirman ustedes la hipótesis de Herbert Simon sobre la racionalidad limitada, en donde la adquisición de información que hagas, ya sea por vía particular o por vía colectiva o social, ¿no? Finalmente no te sirve para predecir el futuro. Y ustedes afirman en las conclusiones de que las malas decisiones basadas, así sea en el sobreuso de la información o en la sobreacumulación de información, de todas formas, tienen efectos en los ciclos económicos. Y un poco es eso de la incapacidad, digamos, humana o natural de predecir el futuro, ¿no? Y pareciera que el trabajo es un argumento en favor no sé si sea una apología de la ignorancia, que ese es el riesgo, es decir, ¿para qué conocemos si de todas formas nos vamos a equivocar? ¿No? O sea, simplemente, bueno, constatar lo que es obvio, ¿verdad? La gran recesión del 2008, pues no pudo, apenas marginalmente fue predicha, digamos, por algunos expertos o actores en el mercado de valores, ¿no? Y lo que ocurre ahora actualmente, incluso con la situación de la economía post-pandemia, ¿no? Donde vemos que muchas de las variables económicas se están moviendo en un sentido contraindicado, ¿no? México viviendo una etapa de sobrevaluación del tipo de cambio en un momento en el que la economía está negra y oscuro, el futuro como nunca antes, ¿no? Entonces, no sé qué reflexión te pueda motivar este comentario. Muchas gracias. Es un trabajo bastante complejo, la verdad. Combinan teoría de juegos y combinan una serie de cosas, ¿no? Que no estamos muy acostumbrados a trabajar por acá. Pero te felicito, los felicito a ambos. Muchas gracias.
Muchas gracias. Y muchas gracias por el comentario. Creo que es un comentario muy importante y en realidad es como una reflexión que podríamos hacer, o sea que es muy relevante en mi paper, pero también creo que es una reflexión un poco más amplia que podríamos hacer sobre la economía conductual, ¿no? Como behavioral economics y el punto de trabajar en estos temas. Y es justo como decías, los modelos económicos que hemos estado haciendo desde hace ya muchísimos años, ¿no? Cuando se matematizó mucho la economía, pues son modelos en los que para poder hacer estas predicciones, como bien lo dices, los sistemas de optimización, ya yendo a un punto como más técnico, tienen que tener condiciones de regularidad, etcétera, para que hagan que podamos resolver estos modelos. Y entonces lo que eso significa es que tenemos que hacer supuestos sobre la racionalidad del individuo que a veces son demasiado fuertes. Entonces, un poco a lo que le apuesta el área de economía conductual, o ¿cómo le llaman? Economía del comportamiento, behavioral economics, es justo como arretar esta noción, ¿no? Y decir, bueno, no, la gente no es racional, la gente no se comporta de esta forma como, ¿no?, súper mecánica, pero también lo que dices es cierto, eso es bastante riesgoso porque entonces podemos caer en el otro extremo de decir, bueno, si no sabemos nada, entonces no se puede hacer cualquier cosa, pero creo que más bien el esfuerzo aquí es justo como encontrar ese punto medio en el que hablamos más como de bounded rationality, o sea, no estamos diciendo irrationality, ¿no? No es como racionalidad o irracionalidad, sino más bien, pues sí, bounded rationality, ¿cómo le diríamos? Como racionalidad, ayúdenme, acotada. Y entonces, en ese sentido, todo lo que hemos aprendido en todos estos años de estos modelos matemáticos tan importantes, etcétera, sí lo podemos seguir usando, pero entonces a lo mejor, y a esto le apuesta la economía experimental, podemos identificar cuáles son los supuestos que más problemáticos, ¿no? O sea, cuando hablamos de racionalidad del individuo, hay un montón de cosas que hay detrás. No sé, de lo que hablé hoy es de algo muy específico que es cómo incorporamos información, ¿no? Y ahí el supuesto clave es que las personas usan el teorema de Bayes para hacer, ¿no?, como el Bayesian updating. Pero hay muchas otras cosas detrás de estos supuestos de racionalidad, o sea, no sé, algunos temas así como más clásicos de economía conductual pueden ser preferencias sociales, ¿no? O sea, uno de los supuestos detrás de racionalidad es que a la gente solo le importa maximizar su utilidad y no me importa a nadie más. Pero bueno, cuando estamos en un mundo social, pues sí nos interesan los otros, y entonces puede ser para bien o para mal, ¿no? Puede ser como, no me gusta la injusticia, ¿no? Y eso va completamente en contra de unos modelos de racionalidad, porque yo solo debería maximizar mi utilidad, pero si tengo aquí como ideas de justicia, entonces eso no es compatible, o si, no sé, reciprocidad, etcétera. A lo que voy hay como muchas formas en las que podemos tratar de entender esta idea de racionalidad acotada, y más bien la propuesta pues a lo mejor con este paper y también mi agenda de investigación un poco más en general es pensar en estos contextos específicos en los que me estoy moviendo, y aquí es información, es tratar de identificar los lugares en los que esos supuestos de racionalidad son más problemáticos. En este sentido, pues la gente compra demasiada información. Si la gente compra demasiada información, entonces eso cambia cómo la va a usar, y a final de cuentas, si quiero hacer si me voy a un modelo más macro y quiero hacer un pronóstico sobre cómo los inversionistas se van a mover, etcétera, en ámbitos un poco más grandes, a lo mejor no está mal también pensar que estos sesgos podrían tener implicaciones ahí. O sea, si la gente, que en estos modelos más macros, si pienso que todo el mundo está siendo súper racional, que está comprando solo la información que necesita, que responde a las diferentes precisiones, etcétera, eso lleva a ciertas acciones que después son como inputs. ¿Cómo se dice? Perdón. En estos modelos más macro, ¿no? Y que entonces afectan las predicciones necesariamente. En fin, lo que estoy tratando de decir es que más bien el punto de este trabajo es identificar esos supuestos que son más fuertes, y a lo mejor, sí es un modelo, o más bien es un paper teórico, a pesar de tener datos y análisis empírico, es un paper teórico en el sentido de que aquí a los que les estamos hablando más es a los teóricos. O sea, si te estoy diciendo que la gente no usa el teorema de Bayes, que la gente no es racional a la hora de procesar información, entonces a lo mejor vamos a escribir modelos donde esa racionalidad sea limitada, ¿no? Y bueno, en este sentido hay un montón de evidencia en mercados financieros, ¿no? Los pánicos, todas estas cosas, pues es lo opuesto a los teoremas de Bayes, pero si encontramos estos sesgos un poco más sistemáticos, si podemos identificar las condiciones bajo las cuales hay más pánicos o que la gente no reacciona suficiente, entonces eso sí nos puede generar mejores modelos. O sea, necesariamente es hacer los modelos más complejos, ¿no? Porque estos supuestos y etcétera es para hacerlos más fáciles de resolver, digamos, pero creo que este tipo de trabajo habla un poco para eso, cómo podemos enriquecer los modelos para tratar de capturar esta racionalidad limitada del individuo. Por ahí va.
Bueno, qué buena sorpresa saber que hablas español.
Sí, perdón, no, la razón por la que presenté en inglés es porque todo esto lo estudié desde el doctorado y entonces terminaría hablando así, yo qué sé.
Desconozco el trabajo, no lo he leído, pero me parece que es un trabajo muy interesante. Ahorita en la presentación pensaba yo que estabas tratando meramente la descripción de una inferencia a partir del principio de Bayes, ¿no? Pero parece ser que más bien que es una teoría de juegos ahí interpretando el comportamiento de personas que tienen información limitada, acotada, y además tiene una determinante que es el costo, ¿no? Entonces, en una realidad donde los factores son muy cambiantes, sobre todo en la actualidad, donde los factores cada vez están cambiando, además por factores a veces exógenos a un microsistema, que si lo llevamos a un nivel macro es muy complicado, ¿no? Entonces la inferencia aquí sería prácticamente más como un cuadro imaginativo, ¿no? Que ahorita tú lo acabas de explicar bastante bien y me gustó. Era nada más ese comentario. Y muchísimas gracias.
Gracias.
A ver, había...
Nada más una pregunta.
Bueno, sí.
Rápidamente. Finalmente me perdí, ya no supe cómo quedó relacionado todo esto con el concurso de belleza. Es decir, la concursante de belleza acumula información y la utiliza para seducir al jurado, pero no sabe cuál es la información que está procesando el jurado, más o menos no por ahí.
El concurso de belleza. Sí, bueno, el concurso de belleza, no sé, es un nombre bastante cuestionable para un modelo de inversiones, etcétera, pero sí, más bien, bueno, si fuéramos a pensar en las implicaciones de esto en el concurso de belleza, es que más bien, ¿qué será? Cuando estoy jugando, y un poco regresando a lo que decías, ¿no? Como que esto se complica porque estamos ahora en un modelo de teoría de juegos y justo el punto de esto es, de este trabajo es qué tipo de sesgos pueden aparecer cuando además de todos los problemas que ya tenemos de incertidumbre, ¿no? Como decías, o sea, la situación económica, etcétera, hay mucha incertidumbre en el ambiente. Aparte de eso, tenemos que coordinarnos con otros que también enfrentan esa incertidumbre y tenemos que formar creencias sobre cómo ellos enfrentan la incertidumbre, qué tipo de acciones van a hacer, porque a final de cuentas lo que yo haga depende de lo que piense que ellos van a hacer y de toda la incertidumbre, en fin. Pero claro, entonces regresando al este concurso de belleza, lo que esto nos está diciendo es que efectivamente, si estamos en un ambiente en el que tenemos que pensar sobre lo que los otros van a hacer, pues sí, es un poco más difícil procesar la información. O sea, no tengo una gran respuesta para el concurso de belleza, lo siento.
A ver, Alejandro Díaz, adelante.
Professor, beliefs matter in your model. The quantum response equilibrium, which you used also, is an extension of the standard model of Nash equilibrium, which allows for errors in choice. The QRE can be viewed as the generalization of statistical models of discrete choice behavior in a game theoretic setting. Quantum response equilibrium would be a solution concept in game theory, and it would provide an equilibrium notion with bounded rationality. A QRE is not an equilibrium refinement, and it can be give us significantly different results from Nash equilibrium. QRE is only defined for games with discrete strategies, although there could be analogs for continuous strategies. The quantum response equilibrium show us that players are assumed to make errors in choosing which pure strategy in the playing game. The probability of any particular strategy being chosen is positively related to the payoff from the strategy. In other words, very costly errors are unlikely. The equilibrium arises from the realization of beliefs. A player's payoffs are computed based on beliefs about other players' probability distribution over strategies. So in equilibrium, the player's beliefs are correct. So with the strategic uncertainty, would we have a Nash or not Nash equilibrium? Thank you, Professor.
Let me see if I understand. So you're asking me whether in our okay, let me take one step back. So quantum response equilibrium, as you mentioned very clearly, it is an alternative to the notion of Nash equilibrium, and it is a concept of, we could call it behavioral game theory, right? So it would be the study of strategic interaction, but under this behavioral lens where people are boundedly rational. So quantum response equilibrium is one of the most popular maybe notions or departure that offers an alternative to Nash equilibrium. And there's these different important assumptions behind Nash equilibrium. QRE relaxes the assumption of best responses to beliefs, but as you mentioned, QRE still requires people to form correct beliefs. It's just that it relaxes that assumption of always best responding, and I think the way that they talk about it is that they talk about a notion of better responses, in the sense that even if I know what the best thing would be, there is always a non-zero probability of doing something different. So that would be the mistakes, and then, yeah, as depending on the stakes of the game, people are less likely to make mistakes when these mistakes are costlier in terms of payoffs. So in our game, the analysis that I showed you was comparing observed behavior in the experiment to the predictions of Nash equilibrium. So we still use Nash as the theoretical benchmark. against which we're going to be comparing these departures. So that is what we do. So kind of taking, if we're doing a test on rationality, we chose to use the rational benchmark as the thing we're going to be comparing our results. And not QRE. Well, first of all, it is QRE with incomplete information is a little bit complicated, but the reason we didn't use QRE is because as I said, we want to identify anomalies and we want to measure the extent of these anomalies. Now, I mentioned very, very briefly, but it's in the paper. It's developed properly. We did look at whether QRE could explain our results, and by that I mean that in a model where there's always a non-zero probability of people making mistakes. Could this be enough to explain the discrepancies that we find with respect to the theoretical benchmark? And the answer was no. So even if we try to estimate, so you have this free parameter in quantum response equilibrium models, you have this free parameter that measures the extent of, let's call it this irrationality, or I really don't like using the word irrational, but this departure from rationality. So even when we fit that, we find a value for that, the QRE would not be able to predict what we find.
¿Había alguna pregunta por allí al fondo? Sí, David.
Well, congratulations for the presentation. Well, certainly I don't know if I should make my question in English or Spanish.
Como quieras.
My question is, how can you apply this topic in Mexico? I mean, how do you see the policy signals in Mexico, and how can you get a relationship with these ones and the quality shows that we make in Mexico?
Te contesto en español. Híjole. A ver, muy buena pregunta y es una pregunta muy difícil también. Pero es muy importante. Lo primero es que un poco recalcar lo que decía hace ratito, o sea, esta investigación es muy micro en el sentido de que estamos, ¿no? Y con los experimentos, sobre todo cuando haces experimentos para probar teoría o para ver que también funciona la teoría, la forma en que yo pienso en los experimentos es como, o sea, hay un modelo micro de toma de decisiones y entonces hay un mecanismo que es el que estoy interesada en entender mejor y entonces así como verlo con microscopio, ¿no? Busco así el setup, perdón. Como más básico, le quito todas las distracciones y me enfoco así como en las tensiones del modelo para tratar de entender qué es lo que está pasando. Entonces, en ese sentido es como lo más alejado a hablar de la economía en el mundo real. Pero, por otro lado, lo que también decía hace rato es que, a final de cuentas, lo que estamos tratando de hacer aquí es identificar desviaciones sistemáticas en relación a estos supuestos que están detrás de muchísimos modelos. Entonces, en algunos otros de mis trabajos, el esfuerzo es un poco el mismo, tratar de entender, ¿no? Cuando hay diferentes flujos de información, o sea, cómo la gente reacciona a este tipo de información. Y en ese sentido, a lo mejor sí podríamos hacer como especular un poco cómo esto podría afectar el comportamiento de agentes económicos reales. Primero, espera, voy a tomar así como un paso atrás. A ver, te explico lo que está pasando en mi cabeza. Me preguntaste cómo podemos pensar que esto se aplica a México, y para responder esa pregunta la voy a hacer en dos pasos. Primero, pensar cómo este tipo de sesgos que identificamos se pueden aplicar a agentes mexicanos a lo mejor, y después cómo estos modelitos tan micros se pueden aplicar a la economía más, pues sí, más general. Entonces, pequeñísimo comentario sobre lo primero. Cuando hablamos, y en mi primera diapositiva dije, ¿no?, que cuando hablamos de estos sesgos de comportamiento, tienen que ser sesgos sistemáticos, y ahí la palabra clave es sistemáticos, o sea, no puede ser algo aleatorio, ¿no?, que de repente, o sea, la teoría me dice que tienen que hacer las cosas así y la hacen diferente, pero si cada vez que lo apruebo con distintas personas, cada quien lo hace como quiere, entonces eso no es un sesgo, eso es, o sea, random, ¿no? Entonces, desde Kahneman y Tversky en los 70s, que fueron como las personas que empezaron a trabajar en estas cosas de economía conductual, o sea, como buscar ahí esos, no necesariamente fallos, pero a lo mejor sí, en los supuestos de racionalidad, lo que se ha hecho un esfuerzo bastante grande desde hace muchos años por asegurarnos de que estas cosas sean robustas. Y una de las dimensiones en las que buscamos que sean robustas es justo como, ¿no?, en diferentes culturas, etcétera. Entonces, a ver, por ejemplo, no necesariamente lo que yo presenté hoy, porque, bueno, lo corrí con unos estudiantes en UCSD, también en UBC, que es donde está mi coautor, pero, por ejemplo, la forma en que la gente enfrenta el riesgo, ¿no? Nuestros modelos asumen que tenemos una aversión al riesgo y entonces ahí tenemos un parámetro que va a determinar el coeficiente de la aversión al riesgo. Bueno, los modelos normalmente asumen que esta aversión al riesgo es relativamente constante. El trabajo que hicieron Kahneman y Tversky y que se ha seguido haciendo es justo decir que esto no es así, que la actitud al riesgo depende de muchísimas cosas. O sea, cuando la gente está enfrentando riesgo porque puede perder dinero, es muy aversa al riesgo, pero cuando estás enfrentando situaciones en las que puedes ganar, haces lo opuesto, ¿no? Entonces, y bueno, o sea, hay experimentos específicos y como hay cosas que hemos aprendido como muy claras, y lo corren con gente en Israel, en Estados Unidos, en México, en donde sea, y hay sí hay ciertas cosas que son muy comunes al ser humano en distintas culturas. Entonces, bueno, por ahí es un poco mi respuesta, que si somos suficientemente cuidadosos al identificar estos sesgos y trabajamos suficiente para asegurarnos que estos sesgos de verdad están ahí de forma sistemática y que no es nada más algo artificial porque hice el modelo del concurso de belleza en vez de hacer otro que es un poquito diferente o tal, o sea, sí se requiere un poco más de trabajo y más de tiempo para asegurarse que estas cosas en realidad estén ahí. Entonces, a lo mejor podemos decir que sí hay cierta tendencia ¿no?, de las personas para comportarse de esta forma. Regresando un poco a lo que decía hace rato sobre los pánicos financieros, o sobre cuestiones, por ejemplo, o sea, este no es un modelo, no usamos este mismo modelo, pero algo muy, muy similar. Podemos usar este tipo de modelos para entender cosas de crisis cambiarias, ¿no? O sea, crisis cambiarias, cuando les hablaba de un estado de la economía, pensemos que el estado de la economía, o sea, no sé, México en el 94. No, o sea, hay inversionistas extranjeros que tienen pesos y tienen que decidir si los cambian por dólares o no, y porque a lo mejor hay una devaluación. Entonces, el estado de la economía puede ser o puede estar relacionado con la probabilidad de que haya una devaluación, digamos, el nivel de reservas en el Banco Central. Y entonces tenemos como estas fuerzas que presenté en el modelo, ¿no?, que son eso, el nivel de reservas en el Banco Central, que es como la información pública que medio que sabemos, pero no sabemos, porque ahí hubo un anuncio del Banco Central, pero bueno, no sabemos. Y aparte hay información privada, ¿no?, que a lo mejor yo trato de entender qué está pasando, y están las dos fuerzas. Está la fuerza fundamental, o sea, la incertidumbre fundamental, que es justo eso sobre el estado de la economía, pero también hay incertidumbre estratégica, porque yo no sé si las otras personas van a también a tratar de cambiar su dinero, o sea, si va a haber una corrida. Entonces, bueno, estos modelitos sí nos ayudan a entender como estas situaciones un poco más aplicadas, y en este tipo de circunstancias entonces decimos, bueno, o sea, digo, es un modelo diferente. Estoy pensando en un paper que escribí que tiene que ver con esto así mucho más claro, pero lo que voy es que si encontramos cierto tipo de comportamiento en estos ámbitos, que como dije, que es sistemático, que demuestra que la gente reacciona demasiado a ver cómo se comportan las otras personas, ¿no?, que tendría que ver con pánicos financieros, etcétera. Entonces, a lo mejor eso sí nos puede ayudar un poco más a entender esto, y desafortunadamente no te puedo decir algo concreto sobre México, pero me gustaría aplicarme un poco más. A veces uno se pierde teorizando.
Está bien. Bueno, había dos preguntas más, una de Pedro Raca y otra de Cuauhtémoc Calderón. Empieza Cuauhtémoc, si no. Doctor Calderón.
Sí, bueno, pues muchas felicidades por, digamos, por el grado, pues, de abstracción de tu trabajo. Y yo he visto varios trabajos de economía experimental, y bueno, uno no usa teoría de los juegos, y digamos, el eje de toda esa rama de la economía es cuestionar el principio de racionalidad, ¿no? A nivel, pero a nivel, pues, micro, ese es el asunto. Ahora, mi pregunta es esta, digamos, en el plano, pues, micro, pues, yo creo que los agentes no son racionales. ¿Sí? Entonces, pues, estás cuestionando el paradigma dominante, pues, de la economía, que es el equilibrio, pues, general, ¿no? Todos los presupuestos de Arrow, de Bro, toda la micro. Entonces, es algo, digamos, que pone en jaque los fundamentos axiomáticos, porque el modelo político general, pues, es un modelo axiomático que va de lo abstracto que va bajando las hipótesis. Y en ese sentido, mi primera, pues, pregunta es, tú hablas de que estudias una parte de toda esta parte. Entonces, bueno, ¿cuáles serían las hipótesis o tus axiomas de los cuales tú partes para introducirte a esto? Ese es uno. Dos es, digamos, yo no estoy muy seguro de la teoría pues, de los fundamentos micros de la macro. Más bien, yo creo en otro paradigma, que es el post-keynesiano, en donde tú tienes una incertidumbre radical. ¿Qué quiere decir? Pues que no puedes medirla. Entonces, y en ese, pues, sentido, yo te voy a decir, bueno, digamos, todas estas conductas individuales en el plano, pues está agregado, se van a neutralizar. Entonces, tú no puedes decir que, o sea, como digamos, Kildelberg es el primero que habla de las fases del ciclo general. Hay pánico, etcétera, ¿no? Digamos, esa es la referencia, pues, clásica para el análisis de las crisis y los ciclos, en donde él lo que dice, lo que me interesa es el estudio de las crisis generales, no de las crisis industriales, no de las crisis financieras. Entonces, digamos, las crisis, aunque sean financieras, son fenómenos macroeconómicos, en donde los individuos tienen que responder. Digamos, una crisis, pues, financiera no es producto de una mala decisión. En la bolsa, pues, de valores, digamos, esa es una visión errónea, ¿no? Sino que hay variables más grandes, como la inversión, sobreinversión, el comportamiento de las tasas, pues, de interés. Entonces, digamos, y yo te puedo decir, en términos de lo que es una racionalidad, tú no puedes comparar la llamada racionalidad de un campesino en Chiapas ante el riesgo de la crisis que un agente de Wall Street, digo. Es muy diferente. Entonces, el problema es que hay que definir el tipo de agente con el que estás tratando. Si es una persona muy educada que está en Wall Street, ¿verdad? y que se la pasa ahí, pues obviamente que puede que sus decisiones tengan algún efecto, pero hemos visto que no tienen ningún efecto. Al final, como yo te digo, hay un proceso como de promedio, ¿no? En donde es cero, ¿no? suma cero, o sea, no hay efecto. Entonces, esa es mi pregunta y mi observación, y me parece muy importante la vía que has tomado, porque hay que estudiar segmentos de la realidad bajo ciertos presupuestos, digamos, axiomáticos, que tú vas a decir, bueno, pues es como ir haciendo una operación quirúrgica, pues, del apéndice, ¿no? Entonces, abres y vas a un punto muy preciso, pero lo que hay que tener muy claro es que estas a priori sean realistas, no cosas que no tengan ningún fundamento. Bueno, gracias y yo te felicito por tu trabajo. Me pareció muy bueno.
Gracias, muchas gracias por el comentario. Sí, bueno, a ver, primero empiezo con esa segunda pregunta y después regreso a los axiomas. Sí, o sea, claro que esto es como un paradigma diferente porque estoy hablando de modelos microfundados, ¿no? Como bien lo dices, y en estos modelos microfundados, pues justo es eso, vamos como estas tomas de decisiones, etcétera. Estoy de acuerdo en que hay, bueno, a ver, incluso en los modelos muy microfundados en los que asumimos que hay ¿no? un continuo de agentes, las decisiones individuales tienen cero efecto, ¿no? Ese es como todo el punto con este tipo de modelos. Si tienes un continuo de agentes, número infinito de agentes, entonces cada decisión individual no tiene efecto, y además no solo es eso, sino que las personas saben que las decisiones individuales no tienen efecto, entonces a veces incluso hasta, ¿no? Bueno, en fin. Pero creo que sí hay ciertas cosas que se pueden ir moviendo como un colectivo. Como lo dije hace rato, creo que el punto de lo que estoy haciendo aquí es como tratar, o sea, le estoy hablando justo a estos modelos más microfundados para entender, pues eso, ¿no? Cómo se toman decisiones, cómo se procesa la información. Y a lo mejor no sé, como el objetivo o lo que quisiéramos es pensar que cuando existen estos sesgos sistemáticos, y no estoy hablando necesariamente de lo que identifiqué aquí, sino un poco más en general, como en este ámbito de economía conductual, etcétera. Cuando hay estos sesgos sistemáticos, este comportamiento que muy claramente va en contra de los modelos que normalmente usamos, no es tanto que la decisión de una persona vaya a tener un efecto, pero más bien que estos sesgos sí llevan a distintos resultados que tienen que ver con, ¿no? con la decisión de muchos agentes. Regresando un poco al ejemplo que decía hace rato de la forma de modelar riesgo, ¿no? Si la actitud ante el riesgo depende de algún contexto específico, entonces, bueno, eso sí puede tener un efecto general, ¿no? O sea, sí creo que es importante también estar consciente de que estos supuestitos que tienen más que ver con decisiones individuales también pueden después tener efectos en pues, outcomes. ¿Cómo digo outcomes? Como, sí, bueno.
En los
resultados, sí. Exacto.
O sea, un comentario ahí, nada más un comentario. Tú lo que me es como un efecto, pues, de mariposa, ese es
a lo mejor, por ahí va.
en la teoría, pues, del caos, es eso.
Un poco, y a ver, y hablando,
O sea,
por
pero
ejemplo, como hace rato que hablé un poquitito nada más como estas ideas de ataques especulativos, etcétera, pues a final de cuentas, o sea, si se generan estas creencias en cascada, sí se pueden generar pánicos financieros que están basados en decisiones individuales. O sea, no sé, si vemos que George Soros se mueve de una forma, digo, y no estoy hablando como de inversionistas así con nombre y apellido, pero si hay algún jugador grande en mercados financieros que se mueve de una forma, la gente tiende a seguirlo, aunque a veces la información que poseen en ese momento no sea consistente con el movimiento que vieron de este jugador grande, pues la gente tiende a seguir, y si pensamos cómo modelar este tipo de comportamiento, es un sesgo informativo. O sea, le estás poniendo demasiado peso a la información de cómo se movió esa otra persona. Entonces eso lo podemos regresar muy fácilmente a un modelo donde en vez de usar el teorema de Bayes, le ponemos, o sea, el sesgo de la información es ponerle demasiado peso al movimiento del jugador grande. Entonces, si todos tendemos a hacer eso porque es un jugador demasiado grande, pues los resultados sí van a ser distintos y entonces puede haber aquí no sé, puede haber crashes, puede haber efectos un poco más grandes.
Bueno, Pedro, pero sí le vas a
Muy
entregar
bien.
una constancia. Bueno, entonces aprovechamos para cederle la palabra al doctor Pedro Raca, director del departamento, que le va a entregar la constancia a la doctora.
Gracias, Oscar. Gracias, doctora Trevillo. Muy interesante su ponencia y gracias a todos los participantes. Sí, bueno, le hago ya una constancia por su participación en el seminario.
Muchas gracias. Muchísimas gracias.
Y bueno, por eso damos concluida la edición del seminario de hoy. Gracias a todos. Buena tarde.
Muchas gracias a todos. Gracias, gracias. Hombre, gracias. Para la próxima debería traer un reloj, yo qué sé. Sí. Gracias. O sea, sí son Sí, no, gracias, estuvo. Pero no, muy buenas las preguntas. Muy bien.
Gracias, doctora.
Muchas gracias, hasta luego.
Pensé que me iban a preguntar porque aquí les gusta más